This is problem number 1 from section 6.4. It says, assume that theta is an angle in standard position whose terminal side contains the point -8, 15. Find the exact values of the following functions. So I like to start these problems out by making a little drawing. And when I make the little drawing, I'm going to mark this coordinate. So -8 tells me to go to the left, -8. So I'm going to mark this as being -8. And then up to 15. So I'm just going to mark this up here as being 15. Find that spot, -8, 15, which was up there. And then I can draw the triangle off of the x-axis like so. So this is my theta. If you draw the picture first, it makes the problem super easy, because now we know that this side is -8, this side is 15. So I can go through and I can find this side, which I know this side to be, let's see, that side is going to be Pythagorean theorem. So I need the hypotenuse side. I'm going to say the hypotenuse is squared is going to equal 15 squared plus -8 squared. And I can go through and I can write those down as 15 squared plus -8 squared. And then remember, I have to take the square root of this, so that's the hypotenuse squared is 289. So I'm going to square root that. So the hypotenuse is the root of 289, which is root of 289. 17. So I know the hypotenuse is 17. Now once I have this triangle, it makes all of these very easy to come up with. So first of all, we know that sine is opposite over hypotenuse, which is, in our case, that would be, opposite would be 15, right? This is the opposite side, this is the adjacent side. So that'd be 15 over 17. So cosine is the adjacent over the hypotenuse. So cosine is -8 over 17. And tangent is the, that would be the opposite over the adjacent. And that's going to be, in our case, 15 over -8. So -15 over 8. And then finally, we're going to get these cosecant, secant, cotangent. Now, these are the ones that are a little bit more difficult. I personally like to use the reciprocal identities for trig to do this. Now, I think there's some other identities out there. There's some other identities out there where they say like maybe x over r and so on and so forth. But for me personally, I like the reciprocal identity. So I know cosecant is 1 over sine. So whatever I get for sine, cosecant is 1 over that. Well, 1 over, so if we write this down here, 1 over 15 over 17. Remember, you flip the bottom and multiply the top, so you end up with 17 over 15. So cosecant is the reciprocal of sine. That's what they're saying there. So whatever sine is, if it's 15 over 17, cosecant is just the exact opposite, which is 17 over 15. So these are all reciprocal identities. That means secant, if you look at secant, that's 1 over cosine. Well, secant is the reciprocal of whatever cosine is, so it's -17 over 8. And cotangent is the reciprocal of tangent. And so we can see that here, right? Cotangent's 1 over tangent. And we can just flip that, and that's -8 over 15. So once you get the first 3, your sine, cosine, and tangent, the other ones are easy because they're the reciprocals. That's problem number 1.